Hi everyone, so in this video I want to explain why we can observe multiple internal rate of returns for a given stream of cash flows. So let's consider a project or a stream of cash flows for an oil extraction project. So in year zero you have to invest $210 million, and from year 1 to year 9, you receive positive cash flows from selling oil to your customers. But at the end of the project, what we observe is that we have to pay some cleaning up costs to clean the project location. So you have a negative cash flow at the end of the project. We want to see and decide whether we should invest in this project or not. The discount rate or the required rate of return or cost of capital for this investment is 8%. In other words, investors will decide to invest in this project if and only if the return that they can earn on this project is equal to or larger than 8%. Okay, first I want to find internal rate of return. So let's talk about the definition of internal rate of return. Internal rate of return is a discount rate that makes net present value of a project equal to zero. In other words, it is a discount rate that makes the present value of negative cash flows of the project equal to the present value of the positive cash flows of the project. So when we set NPV or net present value of a project equal to zero, we find internal rate of return or IRR. So if you look at the equation that we are solving when we are trying to find internal rate of return, you observe that the left-hand side is a nonlinear function. And as you know, a nonlinear function can have no roots, can have one root, or can have multiple roots. So mathematically, when you are solving for internal rate of return, it is possible to have multiple internal rate of returns or no internal rate of return or only one internal rate of return. So what is the condition for having multiple internal rate of returns? Regarding projects, we observe that we can have multiple internal rate of returns when not all the negative cash flows of a project happen before the positive cash flows of the project. So in other words, when you have a negative cash flow in a project after positive cash flows, you can have multiple internal rate of returns. Or whenever you have more than once a change in the sign of the cash flows of a project, you can have multiple internal rate of returns. So first, I want to find the internal rate of return if you have more than one internal rate of return, I want to find internal rate of returns for this project. How do we do that? So we have the cash flows of the project. I create a table. In this table, you should have some initial guess for internal rate of return of the project. So I consider values from 1%, 11%, 21%, 31% to 100%. Then I use the IRR function that we have in Excel. IRR function calculates internal rate of return for a given stream of cash flows. So you should choose the stream of cash flows. Then you should put a comma and you should choose the initial guess that you have for internal rate of return. And you should close the parentheses. Because I want to extend this formula later to other cells and I want the cash flows to be fixed in all the IRR formulas that I use in other cells, I put a $ before the alphabetic part of this cell and before the numeric part of the cells related to my cash flows. Okay, after that, I click enter. So if you want to increase the precision of your internal rate of return that you find, just press this button. It will increase the number of decimal points. Then I extend this formula to other cells, and you can see that the Excel gives you internal rate of return given different initial guesses for internal rate of return. As you can see, I find two internal rate of returns. One of them is 6.77% and the other one is 12.58%. Okay, so we found two internal rate of returns for this project. Now, I cannot use internal rate of return rule to decide whether to invest in this project or not. Based on internal rate of return rule, you invest in a project whenever internal rate of return of the project is equal to or larger than your cost of capital, which is here is 8%. So here I have two internal rate of returns, so I don't know which of these internal rate of returns I should choose in order to make a decision. So in these cases, you don't use internal rate of return to make a decision regarding investment in a project or not. You can either use modified internal rate of return, or you can use the net present value of a project for a given discount rate that you have, and use the NPV rule in order to determine you want to invest in a project or not. If NPV of a project is positive, you invest in the project, and if it is negative, you don't invest in the project. Okay, now I want to talk about, I want to explain why we observe two internal rate of returns or two rate of returns for one project, for one stream of cash flows. So let's do that. In order to do that, I calculate two parts of my net present value. So net present value of a project, as I told you, is the sum of the present value of positive cash flows and present value of negative cash flows. So I calculate present value of positive cash flows separately, I add them together, and then I calculate present value of negative cash flows and I add them together. By adding present value of positive cash flows to present value of negative cash flows, I find my NPV or net present value. So let's do this. In order to find the present value of positive cash flows, for each year, you choose the cash flow that you have. Here is $82.5 million. You divide it by 1 plus interest rate that you want to use for discounting. And here the cost of capital or discount rate is 8%. And then you send it to the power of number of periods that you have to bring back the cash flow. And here is only one period. And then you click enter. You do the same thing for other years. So you divide the cash flow, positive cash flow that you have with 1 plus your interest rate of 8% to the power of number of periods that you want to bring back the cash flow, which is 2 years. And then you click enter. So in this way, I calculate present value of all positive cash flows and then I add them together. In order to add them together, I use the sum function. So how do I use the sum function? You just write sum and then choose the sum function in Excel and then choose all the positive present values that you want to add together and then close the parentheses and click enter. So this is the sum of the positive cash flows that you have. Now I find the present value of negative cash flows. My negative cash flow, my first negative cash flow happens at time 0. It's minus $210 million. So the present value of a cash flow that happens at time 0 is exactly equal to that cash flow because it doesn't get discounted. The present value of another negative cash flow that I have, that cash flow happens at time 10. In order to find its present value, you just divide that cash flow. So let me do this here. So you divide that cash flow with 1 plus your interest rate or discount rate that you want to use. And then you close the parenthesis and send it to the power of number of periods you should bring back the cash flow and click enter. Then I find some of the negative present value of negative cash flows. So I sum these two cells that I have and I click enter. So in order to find net present value, I add present value of positive cash flows to present value of negative cash flows, and it gives me NPV. Okay, so I've already found internal rate of returns for my project. Now what I want to show you why for a given stream of cash flows we observe two internal rate of returns. I create three tables. In the first table, I calculate sum of present value of positive cash flows for different interest rates or different discount rates, okay? In the second table, I calculate present value of negative cash flows for different interest rates, okay? So instead of, for example, 8%, I use interest rate of 2%, 3%, 4% to 25%. So in the second table, I consider two other columns. In the last column that you can see, I consider the present value of negative cash flow at time 0. This cash flow that is negative and happens at time 0 is always fixed. It's minus $210 million. So it doesn't get, this cash flow doesn't get discounted because it happens at time 0. Then I create another column, and in that column, I find the present value of negative cash flow that happens in year 10, right? So this is the present value of the negative cash flow that happens at the end of the project. Okay. And finally, then I can create another table that contains net present value. Net present value is the summation of the present value of positive cash flows with present value of negative cash flows, and that's it. Okay, first of all, I want to show you how I create one of these tables so that you can replicate this for yourself. I've copied the first table here, and I've copied all the interest rates that I want to find present value, a sum of present value of positive cash flows for. So it's just arbitrary. I just put from 2% to 25%. In order to create a data table, you should in this column you should choose the formula that you want to calculate for different interest rates. The formula that I want to calculate for different interest rates is the sum of present value of positive cash flows. Okay, so I choose this cell. And I click enter. Then I choose the area or the cells that are going to make my data table, and I will go to the tab data. Then I go to what if analysis, and I choose data table. In this section, in this window, you should choose the cell. That you want Excel to change in order to create this empty column, to fill this empty column in your table. So what I want Excel to consider different interest rates and calculate this sum of present value of positive cash flows for me. So the cell that I want the Excel to change is the cell of my discount rate. I want Excel to use different interest rates instead of this discount rate of 8%. So in this section, column input cell, I choose the cell that is related to my interest rate. So in other words, I'm telling Excel to put different numbers, different discount rates in this cell of my initial discount rate and calculate the total present value of positive cash flows. Then I click OK, and Excel calculates all of these values for me. You can see that these numbers are the same as what I already had. Okay, so this is how you use data table to calculate a function for different values of, for example here, of your interest rate. After calculating all these tables, as I explained to you, you observe something very interesting. So I want to show the graph for net present value. So let's look at the graph for net present value. As you can see, net present value of a project is a non-linear function, and as you can see, it becomes a 0 in 2 points. So just from looking at this graph, you understand that you have two internal rate of returns. Okay, why this happens? Why I have two rate of return for one project, for one stream of cash flows? Let's talk about that. Okay, we have two tables. In the first table, I have sum of the present value of positive cash flows. In the second table, I have sum of the present value of negative cash flows in that project. Remember, negative cash flows of this project can be categorized in two groups. One of them is a negative cash flow at time 0. It never gets discounted and it is always fixed. Another negative cash flow is the cash flow that happens at the end of the project, and when you calculate its present value, it gets discounted. Okay, so let's look. We start from an arbitrary interest rate of 2%. When we calculate that, when we use this interest rate to find the present value of positive cash flows and then to find the present value of negative cash flows, we observe that present value of your positive cash flow is smaller than present value of your negative cash flows. That's why your NPV is negative. Okay, now what I do is that I start to increase the interest rate. What happens when I increase the discount rate? When you increase the discount rate, you value future cash flows less and less. So, as you can observe, present value of positive cash flows starts to go down because now you are using a higher discount rate. But at the same time, present value of your negative cash flows goes down too. And it seems that the present value of your negative cash flows decreases at a higher rate. Why is that? Because you have a negative cash flow that is in year 10, it is further in time, so it gets discounted more than positive cash flows that happen earlier in time. So let's look at the cash flows. You see, your negative cash flow is in year 10. So when you discount it, the effect of discounting for this cash flow is more than the effect of discounting for cash flows that happen earlier. As a result, when you increase your discount rate, you observe that the sum of the present value of negative cash flows drops or decreases more than sum of the present value of your positive cash flows. So you observe that NPV starts to go up, and it gets close to 0. So that's why you observe that NPV becomes 0 at 6.8%, which is your first internal rate of return. Okay, but why do we have two internal rate of returns? Okay, now take a look. After your NPV increases and gets close to 0, and then it becomes positive at 7%, if you increase your interest rate, what happens? After 7%, when you increase your interest rate, the present value of your positive cash flows start to decrease more and more because now you're discounting them at a higher rate. The present value of your negative cash flow in year 10 start to decrease again more and more because you are using a higher discount rate. But you have a negative cash flow that is always fixed and it never gets discounted. So as you increase your interest rate above 7%, gradually what happens is that the present value of your positive cash flows becomes small enough such that the present value of your negative cash flows becomes larger than the present value of your positive cash flows. And all of this is because you have a fixed part in your negative cash flow, a part that never gets discounted. So take a look. You see that after 7%, when you increase your interest rate, in the beginning, still you observe an increase in net present value, because in the beginning, still the discount that you have in your negative cash flow 10 years from now, that discount is large enough to make the present value of your negative cash flows smaller than the present value of your positive cash flows. But after some point, after 10%, you observe that when you increase the discount rate, because the present value of your positive cash flows becomes too small and some fraction of your negative cash flow never gets discounted, the present value, the sum of the present value of your negative cash flows becomes larger than the present value of your positive cash flows. So your NPV starts to decrease, and it starts to become 0 and then negative. That's why you find your second internal rate of return. After that, when you increase the interest rate, you observe that as interest rate increases more and more above 13%, NPV becomes more and more negative. Why? Because the present value of positive cash flows become just too small that it cannot make NPV positive. And this part of the negative cash flows that is fixed and it doesn't get discounted because it is in time 0, that makes NPV negative. Okay, so you understand that, I just want you to understand that here we have multiple internal rate of returns because of the location of the cash flows in your stream of cash flows. So in other words, all of observing a multiple internal rate of returns is because how cash flows are placed in the stream of cash flow for your project. It's because you have a large negative cash flow at the end of the project after all of your positive cash flows. Okay, so I hope that this explanation helps you understand better why for a single stream of cash flows we have more than one internal rate of returns. The only reason for observing multiple internal rate of returns for a project is that how the cash flows of the project happen over the lifetime of the project. For example, if the negative cash flow that you had in year 10, if it didn't happen in year 10 and instead it happened, for example, at time 0 or before all the other positive cash flows, you would never observe multiple internal rate of returns. Okay, thank you very much.